All right, everything good? Think so. That's the volume's max. That one too. These videos are very cheap, but they did get the job done. I looked at the one last time and I could hear myself and understand everything, so. They're useful. And all you'll see on the screen, besides me off in the corner, is the board. That's all you'll generally see anyways. I don't know why I put this thing up, but I do. Got that on. All right. I'll tell you what, we're gonna reverse you and see if that does it. Look, did you see what happened? That's right. They fixed it for the last day of class. So, good thing they took care of that one, huh? Oh, thank God. Ridiculous. All right. Let's talk about this exam. Are there any questions on this particular exam before I just go into the final? No question? Yeah, anything you want. Question what? 3? There it is right there. Yeah, yeah. Good. Not now. All right, I'll do a new session today. What you're doing here. Okay. Just got a review for the final. Right, and these problems here, whenever they give you, come on now, what's wrong with you? Whenever they give you the data itself like this, that means they do not have the standard deviation. The standard deviation is not known. You have to use this data to get it. So this is one of those ones that required where you get the standard deviation using your calculator. You have to plug these numbers in. I think I did that in the, let me see if I have these here. All right, I'll put down the numbers that I have for it. So by now you guys are good at putting these things in and getting the mean and the standard deviation?
Yeah.
So plugging that stuff in, here's the numbers that I got. My mean for this was 50,506 1.4286, that's what I got to 4 decimal places. The standard deviation of that same data was 958.
20.
Well, I did 4 decimal places, 1878. And then you have to divide, this one is the one we want. That one, you've got to divide by the square root of n. N equals 7. So have your calculator do that. I ended up picking this 2 decimal places. I got 362, 161.
17.
That can't be, well, if you're rounding till just 0.2, then yes, that can happen. All right, let's get our H naught and HA in there. So the key word here is less than 51,000 words. So that means down here, I'm gonna have mu is less than 51,000. That means up top, I'll have mu is greater than or equal to 51,000. Are we good? Now let me draw a picture of this. So that's the area that we're concerned with, is in that piece there. These tests here use a t-test, if you'll remember, because the number is small. We had n was equal to 7. That means you got to do the degrees of freedom is equal to 6. So we'll use that table in a minute. Let me get the t-score. So my t-score, I'll have the x bar. What do we have for this number? I got negative 1.0 for this. Check and see if you get the same thing.
Is it possible if I can get the test from? No.
I already had it back. Just drop it.
Okay.
I feel for you. I got in an accident on the way home this Thursday, so.
So bad.
You weren't the only one. It was, well, I got out of my driveway. I didn't get back into it. That's right. Just told me to dig it. What's there?
I'm sorry.
I'll check it out. Now you gotta go to, let's check it out. I don't mind. Look, when it comes to these computations, I'm as capable of making mistakes as anybody else. This is not my native environment. I'm a theoretical mathematician. So let's see what we have. We got 50,506.4286 minus 51,000. And then let me divide by 52.165. Look at that. I wonder what I was thinking. You're right, you're actually right. Negative 1.36.
So why I'm wrong here, like,
No, you're right. I was wrong.
no,
I. So that's why it's a good idea to check these things. I got negative 1.36. I gotta go back and fix that thing. If I had to guess, my guess is I must have seen a 3.9 or something like that. Who knows? And now we're ready to get our p-value. It may be the same p-value even though, you know? If it falls between the same two values on the table, it may be the exact same p-value.
What the heck was it? Oh, yeah, table. Let me get my tables here. Does everybody have their tables that they need?
This is, I'm looking on the sixth, the row per six. And we have negative, so 1.36 is between two values. So 0.15 and 0.10, the two values that's in between. You guys following me? You must follow along on this, or you're not, this is gonna be doing any good if you don't actually follow along while I'm telling you about this. Now, this table doesn't have any negative values, but if you look on this table and find 1.36, you will find it in row 6 between two values. So in the row 6, here's the two values that it's between. It's between 1.134 1.440. So the t value for this one here is 0.15. And the t value for here is 0.10. So what do you do when you have two t values? The average. The average of these two will be, I don't know why I put t. T is not the answer to that. Let's just leave those like that. All right, so then our p value then will be the average of those two. So that is 0.125. And then alpha, what was the alpha in this problem? Alpha is 0.10. So with that said, what decision do we make? What decision do we make? Do not reject, correct. P value is greater, so do not reject H9. Anybody?
Which one was this again?
Right.
Three.
Now, the answer is to have the solutions are online.
Okay.
So that will have section on the blackboard has it. Other question?
Proportion.
Yeah, once you see the percentage, you know you're dealing with a proportion.
Yeah, it's.
All right, so researchers suspect that. Okay, so the key phrase I see, well, let's get our information down. Let me put my numbers down that I'm given. They give you a key, what's the key people give?
P, 0.
Well, you can do percent or
Oh, the
double.
percentage 37.3.
Right. And how about the p hat? How about the sample one? Huh? No, p hat is a probability. There's no way it's gonna be bigger than one.
Isn't that?
0.373.
No. That's where you got to put 0.373. This is the one that you take from the sample. This is X over N.
Oh,
X, N.
0.22.
That's what it'll end up being after you do the decimal. It says 99 out of 300. Remember, this is the estimate that you use to try to determine. This is 33%. I'll keep everything as a percent just for now. I'll change to decimals later in the problem. And what else did we need here? You needed the standard deviation of this. You remember what the formula is for that?
P,
You're close. P's in there. There's no question about that. You forgot it. The square root, square root, exactly. Yeah.
parentheses,
Parentheses,
1
minus C
Slash.
slash N.
and
Right, you got it. That's what our numbers in that. P is 0.373. This is where you definitely want to go to decimals. One minus that is 627
divided by 300.
divided by 3. Now you can check my number here. So the other one, see if I was 5. For this one, I got 0.0279. So I've got all my stuff in. The phrase that I keyed in on here was less than. Now here, the thing you're estimating is a proportion. So P is less than 37.3%. And then the other one then is P is greater than or equal to 37.3%.
How did we get 0.7?
This,
Yeah.
I replaced P with that number. That with that number, and that with that. Just, this is how I got it. And then what are you asking me?
It's 0.627, I'll just put these in that.
Oh, are you saying, so, oh, did I? 0 point back. You said 6279? Let's check this out, okay. No, it's 0.0279. That is not, you're incorrect.
No. Okay, I'm trying to figure out how you got the number, like the number to say, because I know you got the 99 divided by 300, which is 33%.
Okay.
33% and, but that's.
The decimal of 33.7.
That's how I was confused, because it wasn't.
You mean you can bring your percentage to that?
Yeah, I didn't do the patches.
So now I'm going to decimals. I'm gonna stick that way. 0.373 is the center. And then 0.33. Now, the proportions we use the normal distribution. So we get a z-score here. Let's see, we're gonna have 0.33 minus 0.373 divided by 0.0279.
Median, right.
That's what I got, I get a 1.5 for it. Now I'm drawing the picture. This is the one that we used on the table. And just let the table tell you the answer.
One of these around.
I get 0.06178. Yep. An outlook for this particular problem. What? This was this problem 5?
Yeah.
Where's my output? 0.05. So what do we do? Which number is bigger?
Alpha,
The p-value.
p-value is bigger, do not reject.
Do not reject. Other questions?
I want to review exams.
So we'll go over those. I'm talking about 4 right now. Again, 4 out of the way, make sure we talk about it. And then that's exactly what I'm going to do, is I'm going to tell you the items that we're going to have on the test. By the way, this is being recorded, so you can use that as well. So we'll just go through the test and I'll alert you to the ones that I'm interested in putting on. Interested in putting on because they're already on. What's that? Yeah, yeah, page notes, sure. Yeah, you're allowed to use the notes. As I mentioned, there's 23 questions on the exam. It's kind of like 4 mini exams. Each test will have material from it. So let's pop out of here. I'm going to do, because it's going to delete, it's going to can't kick me out. So I'm going to open these 3 things up so I'll have them. All right, let's go here. I'm not going to put any of the pictures on this exam. It's just no pictures, it's all computational stuff. All right, so here's the way I'll do it so that you can know how to to look at this thing when you go through your notes. I'll put, here's the test one material here. So this material that I'm talking about would be test one. I make this bigger so you can see it. 36. All right, let me have you back then. So this way you'll be able to tell what problem number we were working on. You remember how you filled one of these things out? What do you gotta, what's the first thing you gotta do? No, that's not true. The first thing we need to know though is how many items there are. So we add up the frequency column,
It's not multiplied, are it?
add it up. So we got 14, I got 25 underneath the frequency column. So then how do you make these numbers?
Isn't it? Isn't it at
5 divided by 25.
That's right, it's 5 divided by 25. Or if you want to, you can use the decimal, certainly. What would be the next entry on that same column?
It'd be 9 divided by.
9 divided by 25. Or if you want, the decimal is 0.36. How about the next one?
6 divided by 5.
6 divided by 25, that's 0.30. 4 divided by 0.5.
I got,
Oh, you want to do 0.24, right?
yeah. 0.24.
Then the next one is what?
Or divided by 25.
The 0.16. What does this column need to add up to be? 100%, or 1. Now, how does this relate to the cumulative relative frequency?
To add them together.
As you go along. Right. So the first one is gonna be the same.
Yes.
You're still gonna have 5 out of 25. I don't care if you use decimals or fractions, I really don't. What was gonna be my next entry then? As a fraction, what would my next entry be?
0.25.
No, that's not a fraction.
A fraction.
Yes, as a fraction, what would my next entry in that column be? A decimal is not a fraction.
It's gonna be 5, 9. It's gonna be 14.
Right, we take the 5 and add the 9 to it, right?
Yes.
So you get 14 out of 25. As a decimal, it is 0.56. This column is going to get to 100% by the time you get to the bottom of it. What's going to be my next entry? 20 over 25. In some way, the fractions are kind of easy for this particular problem. That, we're at 0.80 right now. What's my next one going to look like? 24 out of 25. And we are what, at 0.96? And then finally, on the last one, it's 25 out of 25 or 1.
You are, you're always gonna start with 0.
Well, I don't know. It depends on the problem. I mean, I took the problems from these tests, so you'll probably see the same type of problem. But I can't say that that's true in general. I mean, whatever's in that first spot is what I deal with. That sounded bad. Are we okay on this one? All right, here you're asked, do you guys remember what Q1 and Q3 are? The median, I'm sure everybody remembers, but do you remember what Q1 and Q3 were?
Of the top section.
Well, Q1 was the middle of the bottom data. And Q3 was, so Q1 is called the first quartile. And Q3 is called the third quartile. Technically speaking, the median is the second quartile. So the first thing you want to do is try to find the middle of the data. So if you want to find the middle of the data, you should know how many pieces of data there are. How many are there? No.
Um,
How many individual pieces of data are there in this problem?
so we're
You're not seeing it. How many zeros are listed here?
5.
5 of them. So there's at least 5. How many ones are there? 9. How many 2s are there?
6.
You see, there's a whole bunch of data here. So add up the frequencies to tell me how many items are in the whole thing.
25.
Yeah, it's the same as before. It's the same data as before, so it's still 25. So can you tell me where is located the center from 1 to 25? What is the middle number? You say 50? There's 10 above it and 14 below it. Does that seem right?
Okay.
Unfortunately, you got to do a whole number.
Don't you add 2 middle numbers if you can't have?
Well, let's, in an odd case, you do have a middle number though. That's the data if you're actually to write it out. So where's the center? Does anybody know? From 1 to 25, what's the middle number? I still have not, no, you're not answering my question though. From the numbers 1 to 25, what number is in the center from 1 to 25? 13. Yes. So the median occurs in location 13. So the median is data value 13. Can you tell me what data value that corresponds to in this? Which data value is 13, the 13th one? It's gonna be 1 because you don't even have to go to this. This, I mean, if I made these like millions, you could be playing this game of writing them out. The thing is, look here, by the time you're done with this row, you've already gone past 14 pieces of data. You understand? So stay with me here. You're here at 14 pieces of data. What was the data value right before the last one I got to here? 1. This one right here, that's the median. Now, once you have to do the median first to get the Q1 and the Q3, because as you mentioned, you look at the lower data and the upper data and you try to find the middle of those. So if you look here among the lower data, so here we have how many pieces of data are listed here before the circle.
Sorry, could you repeat that?
And so this is the lower data here. If I look, there's 12 pieces of data. 5 plus 7 more before I get to the 0, or the 1. The point I'm making here is you look at the center of this collection here.
If it's even, you can't.
Would you have to take the average of the two? What are the middle two here? So what numbers, what data values are the middle two when you're going 12? Oh, no. You mean the middle. What are the two middle values? Now, don't say 1, say in terms of 1 through 12. No, 1 through 12. What is the center from 1 to 12?
6.
6 and, no, 7, 6 and 7. You can tell because there's 5 less than the 6 and there's 5 more than the 7. It's exactly in the middle. So on there, and the data that you see there, what data values are both 6 and 7 in this problem? Both 1. So if you look, where are data values 6 and 7? This is data value 6. This is data value 7. What's the average of 1 and 1? What is the average of 1 and 1? 1. All right, so the Q1 I got a 1. The median was also a 1. Now Q3 is going to be the middle of the upper data. That includes this piece here. So I also have 12 pieces of data here. So I want to go and find 6 and 7. 1, 2, 3, 4. I can stop 5, 6, 7. Both of them 2. 6, 7. Okay. So the average of 2 and 2 is 2. Any questions? So I'm bringing these up because these are going to be on your exam. I mentioned that I'll use the same questions, just the numbers will be changed. Okay. Oh, compute the mean for that exact same one. All right, well, let me pull this up. Compute the mean. Let me bring the data back up so we can work with it. Okay, so computing the mean, do you remember how to do the mean for these problems?
You plug them in the
You
calculator.
can plug them in the calculator. Do you remember how? No, you don't do any adding or anything like that. You remember, first of all, you get your calculators ready for data input. So you want to clear them out and we'll put it in. Now, when you enter in the data, you need to enter in both the value and the frequency.
Yes.
My calculator output's 1.48.
Minus 3.
You guys do 1.48? Now, there's a way of doing this by hand. You want me to do it by hand, or are you satisfied being able to do it on your machine? That's up to you. I get paid the same whether you can do it one way or another. Do you guys hear me? You want me to do it by hand also, or?
Yeah.
Okay. Well, you still need to add up the frequencies. That still adds up to 25. It's the same data used for several problems. So this is 25. Usually when I do this, I'll call it X, and I'll call this F. And then I'll make a new column where it'll be X times F. So what is 0 times 5? 0 indeed. How about 1 times 9? 2 times 6 is 12. 3 times 4 is also 12. 4 times 1 is 4. And then you add this all up. It looks to me like it comes out to be 24, 37. So how would you get the mean then? What would be your computation?
And then you divide it by the number.
Right, so we'll give you the numbers. That's what I'm asking you. What numbers am I gonna use?
37, right?
37 will be involved, yes.
Divided by
25. Because remember, F is the number of items. So if you're doing 37, right, exactly right. 37 divided by 25, that's X bar. And if you do it on your calculator, you'll end up with 1.48. If I'm not mistaken, the very next problem is going to ask me the standard deviation of the exact same data, which means that you don't have to do anything else, do you? You've already got the data in there, and it'll already give you that answer. There it is. Wait, compute the sample standard deviation for problem 6. Let me bring that one back up. Whereas let me get the data for problem 6. Oh, it's the same, exact same data, in fact. Let me go ahead and bring it up. So using your calculator, can you tell me what the standard deviation is? All you literally got to do is just go look for it.
1.122.
Yeah, I'm gonna do 1.225. I think that's good. 1.225 is what I have to 4 decimal places. 1.125. Once again, if you want me to do this one by hand. The standard deviation was not nearly as much fun as the mean, I know that, because you have to do all those, it's several columns worth of work. So, if you don't, it don't look like you're in the mood for it, then fun. Estimate the mean, estimate the mean and standard deviation for problem 3. So I'm gonna grab them both and put them up here. All right, let me grab the data from problem 3. And once again, this is an exercise that you can do completely on your calculator if you want. How did we do the estimating for these things? Do you remember what we did? Anyone?
Um,
The midpoint. Right, remember? We called it by the letter M, remember? So I'll put it in here, midpoint.
it's 60
That's the letter
plus
M.
69 divided by 2.
No, not quite. Did you say 69 divided by 2?
No, 60.
Right, yeah, this plus this. Right,
Divided by 2.
and you get 64.5. This is what you act like the X values are equal to instead. This is how you get them. Now, these go up by tens, so once you get one, they're very easy to do. 74.5, 84.5, 94. Get the idea, I think.
104.5. 114.
These are the numbers. And then from here on out, you can just plug these into your calculator in your data and get both of the answers that it's looking for. So the trick is just, once you get the midpoint, then just plug your values in and you can get the mean and the standard deviation. Your calculator do those. Are you able to get these numbers? Good. Okay, that is material for test one. I don't know if I've told her, I think you came in a little later. This is being recorded as well. All right, let's move on to test two. For this particular question, I'm only interested in part B of it. There it is. I don't care about part A, is not something I'm interested in. These are where we started to talk about things called conditional probabilities. Do you remember that? If you look inside, if you look at what I had there, I say, for part B, it says compute the what is that? The probability that a professor wears glasses given that that teacher teaches math. Okay? So first of all, tell me, how many math teachers are there total?
78.
78 math teachers. So that's all we're talking about. Since we're talking about people that teach math, my population is 78. Do you understand? So I don't know if this will help you, but I'll say N equals 78 for that. So our answer is going to be divided by 78. What goes on the top?
32.
Right, the 32. The intersection of wears glasses and math. This is the simplest version of these conditional probabilities. Any questions? I'm not going to bother with problems I know are not on it. So, you know, though, if you know me, you know I love marbles. Plus, I like it too because it's very easy to visualize these. The expected value is a very important topic in this course. That tells you that's the number that corporations are what typically compute to determine profits and things of that nature. All right, does anybody remember how you go about this thing? You got a game here, you pay $5 to play it, right? And those are what you win if you win the game. What did we do first thing, remember? Right, the X represented how much your net win of the game was, remember? So if you, the blue, for example, if you get a blue, how much money did it actually cost you to do that? Right, -$5. So you want like that, call it outcome, call it X, whatever you want to call it, but you're going to need to create some more columns. So the X values that I want are the net payouts. So if you get no money, that means you're out $5. What about the next one? 0. The next one. 5. And the last one? So those are my values, or the numbers I'm interested in. Now, these games, it should make sense to you, whenever you play a game that you pay to play, what do you know to be true in these games? You're going to lose most of the time. That means my answer for this should come out to be negative. If it doesn't, they designed the game incorrectly. And then we need, the next column we need is the probability of each of those things happening. So what was the probability of getting a blue one? N is 25 here. So what was the chance of getting a blue one? 15 out of what?
25.
Right, 15 out of 25, that's 0.6. I'm gonna go with decimals myself, on this 0.6. How about the red? What's the probability of drawing a red one? 7 out of 25, that's 0.28. How about a green one? 2 out of 25 is, I think, 0.08.
Yes, 0.
And then finally, plaid one, that'll be 0.04 then. This is where the game is designed. Notice the big payouts have very small probabilities. We need one more column, and that's where I take the product of x and times its probability. These multiply across. -5 times 0.6 is -3. Next one is simple, it's 0. And the answer to this problem then is what you get when you have this column. This one came out very nice. What does it add up to be in this case?
-2.
-2. -2.0 in fact. So I'll put the answers in dollars. So this is your average loss when you play the game. We good? 23. As I mentioned, it's like 4 mini exams. Would you what? I will in a second. I'm going to copy something. I'll be back there. That's what you wanted? The expected value, I was explaining, I got an accident on my way leaving here, Thursday, right? So that means what's going to happen to my insurance? It will go up. I'm a more dangerous individual now driving around the roads. And of course, if you stay safe for so many years, it goes back down because your risk level changes. But what goes on here is this, the reason why my rates go up is because now my expected value, the cost to that company has gone up. You understand? And so they need to recoup that. So my expected value is not going to be the same as yours, for example. Everybody has their own. Then you'll have a couple of ones dealing with the formulas here. This here is the formula for an OR situation, the probability of A or B. Do you remember the formula for that? You either do or you don't. There's no trying. See what you remember. I've given you all the information you need to do it.
A plus
B of B.
minus A and B.
That's right. So it goes like this, probability of A or B. That equals the probability of A plus the probability of B minus the probability of A and B. So P of A is 0.7. P of B is 0.5. And the A and B is 0.25. I think this ends up being 0.95. I suspect the next one is an and type. Yes, it is. I wonder how the and formulas work, if you guys remember those. Do you remember those very well? The formulas for and, there's two of them. I'll write them both up and then use the information to determine which one is the more appropriate one here. So you'll naturally go and find your formulas for the and situation. And you'll be presented with two of them. They'll look like this. You'll have the probability of A and B. Look at the two formulas, they're not identical. Which one would be the one of those two that I could use in this problem? The first or the second one? Definitely want to use the second one because they gave me the B/A, didn't they? So you definitely want number two, and all you do is plug them in then. The B/A, 0.5 right there. And times the probability of A, which is 0.7. And we end up with 0.35. Any questions? Spinner problem. All right, that spinner has 9 slots on it. So these should be very pretty basic answers here. How many odd numbers are on that wheel? Five odd and 4 even. That's why I chose 9, so you'd have an imbalance like that. So what's the probability of getting an odd number then? 5 out of 9. There's no need to go to decimal when it's such a simple answer, I think, because I'm not even going to use it for anything next. The other one is more complicated. What's the probability of getting a number less than 7 or an odd number? So what you want to do in your mind, give me all the numbers less than 7. What are they? So you got 1, 2, 3, 4, 5, 6, right? That's that one. Now, or an odd number, what are the odd numbers in here? Start from the beginning, please. 1, 3, 5, 7, and a 9. So if I push these together, what kind of a collection do I have then? So this is either that one or this one.
Would be 8.
So you'll have, well, when you put, or you can make a larger collection. So it contains every item that each of the collection has. So I'd rather have 1 through 6. But have I gotten all of them? But then I take care of all of them. No, there's still other things in there that I haven't accounted for yet.
So 7.
7 and 9. All right, how many items are in that collection? 8 out of 9. So the probability of this is 8 out of 9. Alternatively, you could have used the or equation that I just told you about. And broken it up that way. But I really think you should be able to do it in both ways, though. You should be able to visualize it using the formula and see how the numbers set up. All right, let's go ahead and take a break there. What's that? That's what I think. I was trying to avoid traffic by leaving early.
Yes. Oh, it's everything, so. I only want you to. Sure. Even like needs to. I don't know, somebody wants stuff, right? Yeah, okay. See. Yeah, that's what you. Ever. It's not his. You can. Right, but it's not. Said no, this. You're right. You got me wrong. I love that. Oh. That's no. Yeah.
Okay, moving on. On to number 7. From test 2. You guys remember how this works? What do you know about the probability column? What does it have to add up to be? Or 1? So with that, so do you know how to get the letter M then? If you know that adds to add up to 1, what do you do?
Yeah, all of them is in minus it by 1 point.
That's right. So we're gonna have, we know this adds up to be 1. So we'll put them all together. Don't worry about the 0, that doesn't do anything. I'll combine my life terms on the left-hand side. It looks like I get M plus
0.71.
oh, I see, 0.71, M plus 0.71. Okay, then subtract the 0.71. You got your M.
0.29.
I do want to remind you too, if you ever get in a situation where some students will write things when they get desperate, they'll write some unusual things. Keep in mind, the probability is never going to be above 1. I saw several people give me p-values that were larger than 1. And that's, you know it's wrong. There's another one that exploits some formulas. You remember the formulas for these, anyone? These are the conditional probabilities. They have their own individual formulas. And likewise, the other one is going to have the probability of E on the bottom. Notice the numerator is the same in both cases. Can you tell me the probability of E and C? You might find it better if you tell me what numbers is involved with E letter E.
Even on
What are they?
2, 4, 6.
2, 4, and 6. So now I'm looking for this and that. What do they have in common, these two sets? The numbers 4 and 6, don't they? So that's 2 out of 6. And then how many items are in C? I'm sorry, yeah, probability of C, yeah. 2 out of 6. You take a number and divide it by itself, what do you get? 1. No, cancels. Over here, you're gonna have the same numerator, so I'm still gonna have a 2 over 6 up there. Now, how many items are in E? 3 out of 6. Now, there was a cool way of canceling that I did earlier in this semester. You can just drop these 6s off. and you get 2 out of 3. No, I didn't put that on there. I want the mean and the standard deviation for this probability function. I don't know, but this is one of these problems where you build the table up. So the first thing I'm going to do is do another column that is x times the probability of x. So 2 times 0.25 is 0.5. 4 times 3.33 is 1.32. 6 times 0.1 is 0.6. 8 times 0.08 is 0.64. And then 10 times 0.24 is 2.4. Add up that column. So you have that column and that is mu. That's, if you remember, by the way, that's the exact same computation we did for the expected value. No different. Now, so I've taken care of the mean, the standard deviation takes more work. The first thing I want to do is create a column where I subtract mu from each of the x values. So you want to do a column that's x minus mu. So that's where I got to do 2 minus 5.46. I get negative 3.46. 4 minus, that's not a negative 1.46. Then 0.54. 2.54. Then finally, 4.54. Now another column, I want to take all these numbers I just came up with and square them. In particular, if you square a negative number, the negative disappears. So you can literally just ignore the negative when you do these computations. I'm going to go 4 decimal places here. 11.9716. You doing it? Last column. That's where we multiply this one by the probability. You're gonna take P of X times X minus mu squared. And I'll stick to 4 decimal places again. I get 2.9929. That's our last column we need. Now we add it up. Almost done. Does anybody know what the last step is? Yeah, take the square root of it, you got it. So sigma equals the square root of that number. And I get 3.0312. But computational, but there's no shortcutting for this particular problem either. Okay, that takes care of 2. On to 3. I'll need you. I got you. These things, I don't know how many of these we should do. How good are you on the tables? Are you good at using them? If you're aces on them, I'll throw one up and see how you do. You want to try one? Or if you don't want to, we'll go on. You want to try one? All right. Let's pick a hard one then. Let's do this one here. Let's pick number 3. 4? That one looks harder to you? No, we'll do those. That's different. I'm talking about just using the table to get me the area. Do you want to do one of these? All right, we'll do number 3 then. We'll see how you guys do on that. So I have a few problems dealing with the table, obviously. You'll have to do some of those. So you should be able to get both of these numbers directly from the table. These check out. Oh, I made a mistake. That's a zero. Okay, what do you do now to get the shaded region? Subtract, we'll subtract those from one. So this area in here then is 1 minus 0.08076 minus 0.28434. I end up with 0.6349. That's what I got.
Yeah, I do. Okay.
Questions? So you'll have a couple of those to work, of course. The other one is where you go backwards on the table. You get the area in front of you, and then you got to go back and find the Z value. Let's do this one. This guy has all the problems in one shot. Any idea what we should do here? Find the little pieces on the end. It's the same amount, isn't it? So what do I got to do? I have the area in between them. What do you want me to do to get the areas out there? Zero or the one above it? That's the area of the shaded region. 0.908. 0.908.
You decided it's gonna be 0.04.
0.046. 0.046. 0.046. We luck out, 0.046 will appear in this table. But I have a feeling that's not even the right amount of decimals, so it's not gonna appear in this table. If I look 0.046. There it is. I see it's between two values. I don't know if it'll let me do that. I don't want. Let me check that. Let me check your computation for a second. 1 minus 0.908 divided by 2. 0.046 are our numbers. On this table, I find 0.046 to be in the row that is negative 1.6. So if you look at negative 1.6 and move your finger over, it's between the column that's 0.07, sorry, 0.08 and 0.09. So it's in between negative 1.68 and 1.69. So if I have this situation here, what am I going to put for my answer? You're not going to put the negative one. I ask you to put the Z.
1.6.
It's a minor error if you choose to do that, but technically you should give me the positive without asking you for the Z and not negative. All right, split the middle. We good? The tables, I imagine these pictures and tables, you probably dreamed about them.
You know, like,
Maybe, oh yeah, maybe. All right, we'll move on then. Remember how to compute the Z-score, the most basic thing that we had to do for these hypothesis tests. Do you remember what the computation is for this? Right, X minus mu divided by sigma, that's right. Where's my X, 71.5? I'm gonna go, you only need 2 decimal places since it's the Z-score. I get negative 0.71. Any more decimals wouldn't be in use for such a thing. Questions? This was the first time when we dealt, problem 9 here was the first time we dealt with a normal distribution type of a problem. Notice this is not a mean or a sum, it's an individual plant that we're talking about. Not the mean of a collection of plants or anything like that. So we have a vegetable that grows according to the normal distribution. It's got the mu of 7 months. So you're given the mu and sigma, everything's up, there's nothing to have to try to figure out. I also indicate that at 7 months, we have the highest percentage of plants that are ripe for eating. So you know that 7 is the top of the curve, right? That's the middle of, that's all I'm trying to get you to understand there. So what percentage of the plants are ripe between month 7 and 8? So you want to draw a picture. And now we just find the area of the shaded region. So to do that, if you're going to use the tables, you need Z-scores for both of these things. So I made a mistake. Sure did. I didn't need to do this one. What's this number going to turn out to be when I do this? It'll be 0 when you go to the other one, but I just wasn't paying attention. That'll be 0. The other one's more important, 8. That Z-score is 8 minus 7 divided by 0.75. And that's 1.33. suggestions on how to get this area.
Well, that's half, right?
Right, get the white spaces out of the way. And you're right, the left white is what, 0.5, isn't it? And half the data right there. Then this one here, you can look up negative 1.33 in your table, and it'll give you the answer directly. I get 09176. So as we did with that one problem not too long ago, we'll take 1 minus 0.5. Then minus 0.0976.
Four.
Uh, 0.4082. It's like a precursor. This is the simplest version of those hyperbolic tests, or those hypothesis tests.
Number 8,
What about it?
find the leading percentile.
Did I go past number 8?
Yeah.
I sure did, didn't I? What the heck? World. This is just in your table, just look up the place that has 90% of the data to the left of it. So you can draw a picture. If you want to. So this is what we're talking about. We want that z-score that cuts off 90% of the data. That means out in this little land out here, how much is out there? Much is in the little white area. Oh, you, I'm stupid. I don't need to look up any later. You can actually just look this up, turn to the positive side of the table and try to find 0.9. I'm doing extra unnecessary work. Take that out of there. So just look up 0.9 in the table if you can find it. I don't think it's actually there. It's between two values. It's between 1.28 and 1.29. So Z is nestled between those. So we take the average would be 1.285. Any questions?
And that's all you have to do, right?
Yeah, it's finished. All right, so I did that one out of order. I didn't have this one. Yesterday. I don't remember if this one's on there, so go ahead and do it. And if it's not, no big deal, right? All right, so we have a mean of 405. So there's a mu, and they give you a mu and a sigma.
Unknown distribution.
Oh, that's why it's not an unknown distribution. Forget about it. That's not, so I can, now I know for sure. Thank you. This was, I'll see if I can ring a bell for you. These confidence intervals, they had a certain form to them. They look like the following. Remember this? And E stands for an error amount. Now, the sample mean is 250. I'll go ahead and plug that in. So the format is going to look like it's 250 minus E to 250 plus E. And the whole problem is to figure out what E is equal to. So I need to show you a few things here. Are we good there? Now, in a confidence interval, you want it centered, so you want to have the same amount of error on each side. So what we do then is we're going to divide this in two. I don't know how to say this. It's the notation. I have not used this notation, so I don't know if it's such a good idea to bring it up on the very last day of class. But you'll get this half off of the way. The reason I want to bring it up is because you need a z-score based on it. What you want to do is get your table and go find 0.025 in that page.
Yes, that's what.
So find 0.025 in this table. And it's on the negative side. In fact, it's actually the data. You don't have to do the average of two values. If I'm not mistaken, it's in there somewhere.
Yeah, maybe 1.9.
All right, so, but here's what we want. I'll write it for you. You ready? Watch this. The number that they want looks the number that they used in the book. I'll just put Z. This is the notation in your book that everybody else uses. And then when you do the E, you want that exact number. And there's our error. Remember that formula? So if you go back to your notes, I don't know if there was an alpha over two in there, I can't remember. Let me put in my numbers. We just found the 1.96. Anybody remember what sigma was? 20. By the way, this didn't mean anything. If you know the standard deviation of a population, you'll ignore any sample that you'll have. There's no reason. The whole reason of a sample is to estimate that thing that we have. So I have 16, and then I'll divide by the square root of how many of these elements? 50. I get 4.435. Yeah, it comes out on, do you guys get that number? 4.435. And we're ready to finish the problem off. So our confidence interval was 250 minus 4.435 to 250 plus 4.435. Any questions about that? Mistake of the next one on here, I don't ask. How many cuts, so I don't have you figure out an N. All right, so that number 14 is not gonna be on there. All right, so that's the material for the exam. Are there any questions? Then you are free to go. I will see you Thursday. Good luck. I'm gonna go ahead and stop recording.